Okay, so let's do a couple more examples. Just help us understand how to simplify these algebraic expressions. So let's come up with this. Let's say simplify 9 minus 5 times the quantity 2x minus 7. Okay, so here we have a set of parentheses, and what we need to do is we need to clear the parentheses first before we can start combining like terms. So we want to clear the parentheses, then combine like terms. And to do this, we use the distributive property. To clear the parentheses. Okay, so let's take our original expression, 9 minus 5 times the quantity, and I say times the quantity because this is inside the parentheses, times the quantity 2x minus 7. Now remember, PEMDAS still, the order of operations still applies in here. If I look inside my parentheses, I have a 2x and I have a minus 7. And I ask myself, can I simplify anything in there? They're not like terms, so the answer is no. This is actually as simplified as it gets inside the parentheses. The next thing I need to do is I want to get rid of the parentheses, so I take this negative 5. The number that is, the expression that is directly in front of this parentheses is what gets distributed to each term inside the parentheses. So my negative 5 is on the outside, so I have to take my minus 5 times a 2x, and I have to take my negative 5 times a negative 7. Okay, so when I distribute, my 9 stays the same, right? And I'm basically taking my negative 5, multiplying it by 2x. Negative 5 times 2x gives me a minus 10x, a negative 10x. And then I have a negative 5 times a negative 7. That gives me a positive 35. It's important to keep that sign there. So it's a positive 35 or plus 35. Okay, now I don't have any parentheses anymore. So I look and I say, well, what are my like terms? Well, I have a 9 and 35. Those are both constants. And then I have this minus 10x, and it's by itself, right? So the only two things I can combine are 9 and positive 35. So those 9 plus 35 gives me 44, and I have minus 10x, right? Or the normal convention is I always put the term that has a variable first, and my constant always goes at the end. So I have a negative 10x, and what's the sign in front of that 44? Well, it's a positive, right? So I can just say plus 44. So either one of these would be correct. Okay, let's try this one. Simplify 5 times 2y plus 3 minus 2 times 3y plus 1. Okay, again, I'm going to take the distributive property. The term right outside the parentheses is what gets distributed. So I'm going to take my 5 times 2y and my 5 times 3. So I have 10y plus 5 times 3 gives me 15. And again, out here I have a negative 2. Right? So I have a negative 2 times 3y gives me a negative 6y. And negative 2 times 1 gives me a negative 2. So now I've gotten rid of my parentheses. And I say, well, what are my like terms? Well, I have a y, 10y, and a minus 6y. Those are alike. And then I have a 15 and a minus 2. Right? So those are alike. So 10y minus 6y is 4y. And then 15 and minus 2 is plus 13. So my answer is 4y plus 13. Okay, let's do one that's a little bit longer. Simplify. 6 minus 5 times the quantity, negative 2y minus 4 times 2y minus 5. Okay, so again, our order of operations tells us to go inside, right, the innermost set of parentheses and see if we can do anything there. Well, we have 2y minus 5. And again, those aren't like terms, so I can't do anything. So what I'm going to do is get rid of that by distributing this negative 4 outside these. Everything else stays the same, right? I have 6 minus 5. I haven't changed anything there yet. I have 2y. Negative 4 times 2y is going to be minus 8y. Negative 4 times negative 5 is a positive 20. And remember, I put my sign there too, so it's positive 20. Okay, so now I have this expression. Again, I look inside, see if I can combine any like terms. And sure enough, here I can, right? I have a negative 2y and a negative 8y. So before I start distributing this 5, I like to simplify as much as I can inside. So I have 6 minus 5 times the quantity. These two get combined, and I get negative 10y plus 20. Now nothing can get simplified any further inside, so I can go ahead and distribute this negative 5. Right, so I have 6. Negative 5 times negative 10y is plus 50y. Negative 5 times a positive 20 gives me a minus 100. And I look for like terms again. Here I have 6 and negative 100, and I have a 50y. So I'm going to write my 50y, and 6 minus 100 gives me a negative 96. I'm sorry, negative 94. Right? And so that's my answer. Okay, let's do one more example. If I have simplify, 3 times 2a minus 5 plus 2a minus 7 times the quantity 4a plus 1. Okay, so let's take a look again at what we can start to simplify. And if we go into the innermost parentheses, I'm just going to rewrite this part as, actually we could distribute this out, right? So I might say that's 3 times 2a is 6a, 3 times negative 5 is minus 15. Okay, plus, and in here I want to distribute this out too, right? So I can continue writing 2a, I haven't changed that at all, but I have negative 7 times a positive 4a gives me a negative 28a, and then a negative 7 times a positive 1 gives me a minus 7. Nothing changes out here yet because I'm going to simplify what I can inside these square brackets. I have 2a minus 28a gives me a negative 26a, and then I have a minus 7. And at this point I can take away the parentheses. Right, this is like 6a minus 15, and then this is plus. I'm going to put a negative 26a in parentheses because that separates it out, and then I have a plus negative 7, right, or minus 7. So which ones are my like terms? Here I have a 6a and a negative 26a. And then I have a minus 15 and a minus 7 plus a negative 7, right? Okay, so I'm going to combine what I can. My 6a and my negative 26a leave me a negative 20a. And then a negative 15 and a negative 7 leave me a negative 22. So my answer is negative 20a minus 22.